Hi, Gen Math. This is an experiment. With 1 week left in the try, what I really want to try and do is find different ways to deliver curriculum to you, try to teach you, and still be supportive to all my different groups. Next trimester, your class is split up. Skylar and Cam, you are in one group. Mandy and Chris, you are in another group. But we need to cover the same topics. So anything I can do to try and make sure I can spread my talents or help everybody as much as I can is a benefit to class. And so we're going to try a video. Today we're going to talk about, and I'd like you to have your math book open to page 323, lesson 5. We're going to kind of drive home the idea that fractions and decimals are related to each other and try and figure out the part-to-whole relationship. You already know that there's a part-to-whole relationship in fractions. If I take, we'll try this again. If I take, nope. There we go. If I take 2/4 as a fraction, well, 2 you know is the part, and that makes 4 the whole. 2 out of 4, meaning part to whole. 2 is the part, or also the numerator, and the whole is the denominator. This is nothing new. It's something that we've been learning for the most part of this year, that the numerator represents a part and the denominator represents the whole. I could demonstrate this another way through a use of a pizza. Say I cut that pizza into 4 pieces. I give Skylar a piece and Mandy a piece. How much of the pizza did they eat? 2 out of 4 whole pieces. Okay? Nothing new, nothing exciting there. But we can use decimals to do the same thing. You know that if I put this decimal out there, 0.03, we can call this fraction 3/100. THS, 3/100. Here's my tenths. Here's my hundredths. Nothing new. Been working on that for the better half of the week. I know that if I can say it, I can turn it into a fraction. So 3 is my numerator, and this place value tells me the denominator, hundredths, 3 out of 100. And now I have a fraction. 3/100 is the same as 3/100 in fraction form. And now I have a part to whole. Another way to look at this and think of it is, how much can each place value hold? How much can each place value hold? Well, this is a good question. That's why I wrote it. But what we can think of is if I do a decimal point blank, 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 okay? If I put a 1 here, it's not full. That would be the same as saying 1/10. Okay, I could put a 2 here. and it wouldn't be full. That would be 2/10. Two tenths, 3/10, 4/10. I could keep going and going and going. But can I squeeze a 10 in here? Could I put a 10 in here? That's my question. I can't put a 10 in here because it's only one place value. And because it's only one place value, I have to find a digit. Just one digit. Here's another question. I look at this now that I'm noticing this. 10 out of 10. What's this equal to? Should be equal to 1. 1 whole. Well, 1 whole doesn't go in the decimal spot. 1 whole would go out here. So what's the biggest value that I can put in a single decimal place or a single place value? The biggest value that I can put in a single place value is a 9. Nine is the biggest value I can put. Sorry, I can't pause it.
Oh, you're
Yeah. All right, so let's keep moving on here. All right, so let's click over. Let's look at a 100s grid. If I have a 100s grid and I want to represent this part and whole, this decimal would be 25 hundredths, right? Okay. Well, I know this is a hundreds block, so each time I shade, I'm shading 10, 20, then 1, 2, 3, 4, 5. There's my relationship. Well, how many parts do I have here? I have colored 25 individual blocks out of how many total parts? 100. Here, this fraction would be 5/10 or 50 hundredths, depending on which way I look at it. Sometimes you see the decimal, or excuse me, see the zero. Sometimes you don't. Since we see the zero here, it's represented out of 100. Well, I know that half of 100 is 50, so I'm going to shade half. And how many parts do we have? Well, we have 50. 50 individual parts, and we're still out of 100. Over here, I have 3 hundredths, only 3 little blocks. But I still have a part, or excuse me, a whole relationship of 100. But I only have 3 that are parts. Here, it's just tenths, 7/10. Could I also think of it as 7, that's a 0, bad 0 on my part. Could we also think of this as 70 out of 100? Well, sure. 10, 20, 30, 40, 50, 60, 70, and then we're going to shade down. All right, that's all shaded. Well, how many parts are shaded? 70 out of what? 100. So what we're doing is we're still finding the part to whole relationship that decimals, show. Sometimes we're asked to write the fraction for each pair. This is nothing new. Numerator has to match the digit. To what? Well, here's my tenths, here's my hundredths. 2 hundredths, tens, hundredths, thousandths, 3 thousandths, 15 thousandths, 8 tenths, 29 hundredths. This last value tells me, or this last digit tells me the place value. So I have, I have thousandths, and I have 90 of them. Part to whole relationship. Decimals. This relationship, the part to whole relationship, can be shown using decimals. You just have to remember place value. Okay, place value is key. What I'd like for you to do is this needs to make it into your math notebook. This is titled Lesson 5, and the lesson is part to whole relationship using decimals. So here's how we're going to write it. Part to whole relationship with decimals. This is your title. I'd like you to copy this down as your notes and for your understanding. You also have the entire video and this slide to go see how to help you with your homework and your assignments. Again, you can watch the video as many times as you need to help understand the concept, but this needs to make it into your notebook. This is key. I'll hand you your work and you can begin. Thank you.